All right, I'm going to use dynamics. Dynamics means I'm going to use F equals MA. All right, to solve this one. So let's draw us a nice picture here. We got this inclined plane. I'm inclined to draw it like that. There we go. And then we know this is 1.9 meters. We know that this is this distance here is 5.1 meters. Okay, and this looks to be a cylinder, right? Doesn't it? Like there it is, right? Because that's the moment of inertia of a cylinder, right? And we have, acting down this plane, we've got mg sine theta. Part of gravity is accelerating down the plane, right? So that'll be our force, right? Our mg sine theta, right? And then that equals the force needed to accelerate it linearly, right? And then the force needed to accelerate it angularly, we've got to add that, right? Because you have to, not only does it have to accelerate in a translational way, that is to go in a straight line, it also has to have a rotational kinetic energy or rotational acceleration, right? So let's see, torque is RF is also equal to I alpha, right? So F is going to be I alpha over R, right? That's our substitution. That's a lot to remember, I think. I alpha over R, right? And now we can substitute, right? We can use the red pen of substitution. So for this, we can put in 1/2. I know this is like really crazy. I'm using different colors now. And then instead of alpha, we can do the tangential relationship, which is that's A over R, right? So now, go back to blue pen land, right? That's MA plus, and let's make all those substitutions. 1/2 MR squared times A over R, all divided by R. And this is why we never need to know the radius, because the radius is about to go away. That cancels one of those, this cancels the other one, and we end up with MA plus 1/2 MA. Well, MA plus 1/2 MA is 3/2 MA, right? So we've got mg sine theta is 3/2 MA. Mass goes the way of the bison. Now our acceleration is equal to 2/3 g sine theta. Okay. Remember, if it was just accelerating and there was not, it did not have to rotate. The acceleration would be all of g sine theta. But here it's just 2/3 of it, right? Because it also has to rotate. Okay. Okay. And then remember that this side here. Let's try a different color. Let's try cyan, right? This is our opposite side, right? This is our hypotenuse, right? And sine is opposite over hypotenuse. Okay, so the sine of that angle is 1.9, literally over 5.1. So I can make that substitution here, right? I keep changing color here. All right, so that is also, the acceleration is just 2/3 times 9.81 times the sine of that angle, right, is literally 1.9 over 5.1. All right, let's figure that out. Look how much room we're going to have here to calculate the final velocity. We won't need it, but there it is. Okay, so 2 divided by 3 times 9.81 times 1.9 divided by 5.1 is 2.436. So that's its acceleration, and now we can solve for the final velocity. Hopefully we can get that, right? So let's go v squared. Let's do it in this space. Look at this. I've never had that much space left over. Okay, so I'm going to use v squared is u squared plus 2as. And we're solving for v, right? So let's see, let's do it. I guess v is going to be the square root of 0 squared plus 2 times 2.436 times 5.1. All right, there we go. Okay, so 2 times that number I just got times 5.1, and that's what v squared is, and then I'm going to square root that. I get 4.985. All right. I'm so happy I've got all this space left. I'm going to draw a picture of a wiener dog. There's a wiener dog. It's got a very long neck, little tail like this. It's wagging. That's what that is. Okay, so he's very excited because his owner just came home. Anyway, there you go.